Yes, a very good afternoon to all of you. Am I audible and visible to everyone? Yes, a very good afternoon. Yeah. Okay, I think in the last class we have studied about naming of alkanes. Did you people revise the rules? We have studied all the basic fundamentals of that organic chemistry, and apart from that, I have given you rules for naming alkanes. Right? Okay, so as promised, I told you that okay, you people revise it, and then I'll be giving you some questions to do here. So are we ready for that? Right? Will you be able to do? Few questions I'm going to give. You take a little bit of time and then I'll discuss here. Okay? Fine. So the question is, write the IUPAC name of the following. So first one I'm giving you So I'm just giving you 5. Please try them out. Or in fact, let me give you another also. Right. Please try them out and then I'll discuss. Yes, Karthik, whatever it is, but please write down in your notebook. Yeah? No, Siddhi, you didn't miss anything. I have just written the questions here. Nothing, you didn't miss anything. I've just written some questions here and I'm giving them time. And once you are done, just write down done there. Okay. And then I'll be writing the name and you verify whether you have written it correctly or not. Okay. Rather than, typing the answers on this particular chat box, it's better you write down in your notebook. And once I write down here, once you confirm that you are done from your side, and then we are going to check. Is that absolutely fine with all of you? Yeah. So hopefully you remember longest possible chain, maximum carbon atoms you have to see. Yes, now I think you people might have done it. Let us just see here. So this is the longest possible. Either you could have done like this also. It will be the same. So here you are going to write down 2,3-dimethyl butane. Right? I think somebody already answered for this. The moment I have written, so it's good. Now the thing is, here the principal chain would be 1, 2, 3, 4 only. Right? So we can number like this. Or else like this also I could have taken. Now the thing is, somebody might think that why did I go from this side? Basically every time I'm getting a set of what? Let us see here, what is the set? I'm having 2 locants here and there is 1 locant here. What is the set I'm getting? 2, 3, 3, right? But what if I name it in different way or else number it in different way? Let us see that. This is what I've drawn it again. So I can write like this, 1, 2, 3, 4. The same chain I can number like this, and this time I'll be getting the set of locant as 2, 2, 3. Now out of these two cases, tell me which one I should prefer, the first one or the second one which I have numbered. The second one, because we need to prefer the lowest set of locant wherever the first point of difference comes, and whichever set you are getting a lower number, that should be preferred, right? So I should be preferring this. So according to that, what should be the name here? Now the thing is, irrespective of what is the number your substituent is getting, you have to write them in the alphabetic order, right? Don't think that you have to write down in the order of the number which you are giving it. Is this point absolutely clear to you, right? So here it is going to be, I'm having 3 bromo, then I'm having 2 dimethyl butane. I hope people have written this. Is your answer matching? Yes, good. Now for this one which I have written here, now the longest is 1, 2, 3, 4 like this only, 1, 2, 3, 4 like this only. So whichever way you go, you are going to get that only, right? So it is going to be 2, 2, 3, 3 tetramethyl butane, right? Or else any other chain, 1, 2, 3, 4. Everywhere we are getting the same thing. Did we get this answer, everybody? Yes, good. Now for this one, 1, 2, 3, 4, 5. Any way you go, 1, 2, 3, 4, 5 only you are going to get. And this is basically what? Ethyl. So you're having 3, 3 diethyl pentane. Yes, did we write this? Good. Now for this one, I can check like 1, 2, 3, 4, 5 or else 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Like this also I can number 1, 2, 3, 4, 5, 6. So I'll be getting what? 3, 4 dimethyl hexane. So this is 3, 4 dimethyl hexane. Have you written this fifth correctly? Acha, dimethyl. Okay, misprint from my side. Yeah, thank you for reminding me that. So it is 3, 4 diethyl. I think I spoke diethyl only, but I have written it dimethyl. Yes? Okay. Now here, from where I should number? See, don't think that I should be giving lower number to that particular, that particular substituent which is coming earlier in the alphabetic order. You have to always form the lowest set of locants. So you'll be writing 2 bromo, 1 chloro, butane. That's what we are going to write. Correct. So I hope people have written this much. Everybody has done very good. If all correct, wonderful. And those who have done some mistake, please analyze where you have gone wrong. Maybe some rule you might have forgotten. Yes, can we proceed further now? Now let us see naming of some substituents which will be useful throughout for you. Okay. Now first one is alkyl. When I say alkyl, that means from alkane you are removing one hydrogen, and when you remove that you get a substituent whose name you will be naming it as alkyl. From alkane you are freeing one valency, and the substituent which result, that is basically alkyl. For example, if at all I am having methane, this is methane, right? Now the thing is, if at all I remove one hydrogen from here, one valency I am setting it free. Imagine that there is a parent chain here. Getting it? So this one will become methyl. Similarly, if at all I am having CH3, this is basically ethane. Or else you could write this as C2H6. Now if I remove one hydrogen, it is CH2, CH3. So this becomes ethyl. Clear to everyone how alkyl we are writing? Please write this down, then we'll proceed further. And once we are done, let me know. Okay. Now similarly, the way I have alkyl, similarly I am having alkenyl. As the name suggests, from alkene, you remove one hydrogen, you will be getting basically alkenyl, right? Suppose I am having CH2 double bond CH2, it is basically ethene, right? When I remove one hydrogen from here, that means I am freeing that valency and attaching that particular group which is resulting to the parent chain. That's what is meant by removing one hydrogen. So you will be getting CH double bond CH2. We call this as ethenyl, or else I call this as vinyl, right? Common name is vinyl, but somewhere you might see like it is written over there, right? Similarly, if at all I am having CH3, CH double bond CH2, right? This is basically propene, right? Now the thing is, there are like chances, there are 3 places from where you can remove hydrogen. Let us say 1, 2, 3. I'm just numbering it. Okay, numbering it, that means lower number should always be given to the multiple bond. On that basis, I have numbered it so that you come to know from which particular carbon I am removing the hydrogen. So suppose hydrogen is removed from this particular carbon, which is number 1. So will I be getting like this CH3, CH double bond CH, and from here it will be connected to the parent chain, right? Now from the place where you have like removed this, so from that place only you are supposed to number it. That means give number 1, 2, 3. Getting it? From the place where you have removed hydrogen, or from where you have, kind of freed the valency. Now, imagine if at all this is not there, how would you name it? You'll name it as prop 1ene, right? Why? Because the word root is of 3 carbon atom, which is prop. And where is the double bond? It is at one place, right? You remember 2 degree prefix plus 1 degree prefix plus word root plus 1 degree suffix plus 2 degree suffix, right? So 1 degree suffix tells you about ane, ene, ine. So after word root we are going to write down. So we are going to write here prop 1ene. Now the thing is, rather than writing ene, I'll be replacing the e by ile, enyl, because it is a substituent. Did you understand this, what I'm saying? Prop 1 enyl, how it has come? Now, the thing is, if at all I remove hydrogen from the second carbon, so it will be like CH3, C double bond CH2. Are you able to see this? This is the place from where I have freed the valency, right? In this case, the moment from where you have freed the valency and you are attaching it to the parent chain, that should be given number 1, and then you have to decide in which direction you need to proceed for numbering, whether it is on the multiple bond side or this side. And normally always multiple bond gets preference over the longest chain. So here you have to go like this, right? Now the thing is, how would I be naming? For the time being, you forget this. How would you be naming this? This is a substituent now. So it is 1-methyl. And then how many carbon atoms there? For the word root, it is basically 2. So you'll be writing ethene. But the thing is, it is substituent. So you cannot write ethene. You have to write ethenyl, right? So this is becoming 1-methyl ethenyl. Clear? Is this clear to you people? What I have written here? Now suppose if I remove from third one, let me write here. Suppose I am removing the hydrogen from the third carbon, it will be like CH2, CH double bond CH2. So from where I should number 1? I should number here. From the place where I have removed or I have attached that to the parent chain, that should be given number 1. You need not now bother, ma'am, double bond is here. Let it be. Okay. Here is the place where you have attached it to the parent chain. So the name will be here prop 2 enyl, or else the common name is allyl. Allyl is what? This is a vinylic group or not? CH double bond CH2 is vinylic group, you have just seen now. And any sp3 hybridized carbon attached to the adjacent to the vinylic group, that is basically allyl. Is this clear to everyone what we have written here on the board? Please write this down. Then after that I'll give you a question. Suppose I am giving you, write the name of the following substituent. Suppose I am having CH3, CH2, CH3, and I am removing, this is like suppose 1, 2, 3 I am writing, I am removing hydrogen from one place and hydrogen from second, because removing from first and third will be same, right? So you have to tell me the name for that. CH3, CH2, CH2, and another one is CH3, CH, CH3. Tell me this name first and then you can write down whatever allyl and vinyl I have written. Propyl, propenyl, propyl you should be writing with a, you should be writing propyl, right? This is basically propane now. So methane got converted into methyl, and here you have to number from here. This will be 1-methyl ethyl, and you will see this is only your isopropyl later on, है ना? 1-methyl ethyl. 1-methyl ethane is incorrect, Gitika. The thing is, it is not parent chain, but it is a substituent. So you cannot end it with ethane. For the time being, you consider as if you are naming a particular substituent, naming a particular parent chain, but moment you realize it is a substituent, replace it by in by il. Absolutely fine, Gitika. You learn from making mistake only, so need not be sorry. That's absolutely fine. Okay. Understood? That is more important thing. Okay, do one thing, you copy this quickly. I think vinyl everybody has copied or not? Good, understood. That is the main thing. Write this down, then we'll proceed further. Copied also? Can we proceed further in case people have copied? Yes, okay, fine. Chalo. Now, I think I've given you two. Let us say third one. You are having alkynyl. Can you guess what is alkynyl now? Alkynyl will be, from alkyne, you are freeing one of the valencies, right? So here you are having alkyne. When you remove or free one valency from here, you will be getting alkynyl, right? So for example, if at all I am having this, you free one of the valency, this is ethyne. So this one will be now C triple bond CH, and it is known as ethynyl. Clear? Ethynyl. Now there is one more thing which is alkylidine. Alkylidine means if at all you are having alkane, from one carbon itself in that alkane, you are removing two of the hydrogens and you will be ending up with alkylidine. Right? For example, suppose I am having this CH4, it is methane, right? Now the thing is, if at all you remove or free two of the valencies from here, that means remove two of the hydrogens from here, will you be getting something like this double bond CH2? This is double bond in the sense two valencies are free, right? So this is known as methylidine, or else for this only you can call it as methylene. Only for this double bond CH2, it is methylidine. Methylidine you can call for like ethyl or ethane also, like any other group also. But methylene you can call only for this. Okay. Now, if at all I write something like this, CH3, it is ethane. Now from here you remove two hydrogen like this, CH3. From one carbon itself I have removed, right? The thing is, you might come across like this in your haloalkane chapter where it is like ethylidine chloride is there. So you will be having something like this, 2Cl on the same, right? So you will be writing this as ethylidine chloride, right? So it is coming from this only, ethylidine. And make sure that you are not writing ethylene for this. Is this clear to everyone? I'm just freeing this valency. Two valencies are free. That means in place of hydrogen, I can get any other group, any other substituent. So this is ethylidine chloride. And you need not write down ethylidine dichloride because ethylidine itself is telling you that two hydrogens have been replaced by the chlorine. Is this point clear to you? You find this particular thing in your NCERT for the common name. In haloalkane, haloarine chapter. Geminal dihalide. Yes, are we done writing it? Generally it is the case, but it will be satisfied by those two similar atoms only. Otherwise, it doesn't make any sense, right? Okay. Now next you are having, suppose from benzene ring, if at all you remove one hydrogen, you'll be converting it as a substituent. So from benzene, right? If at all you remove one hydrogen, you are getting phenyl actually. That means you are having C6H6. From there you remove one hydrogen, it will become C6H5. Like this also it could be shown sometimes, like this. There will be a parent chain over there, right? Phenyl. This will be helpful when you are dealing with the aromatic compounds naming. Then there are certain derivatives of toluene. This is toluene, right? Now the thing is, you can replace one of the hydrogen, you can replace two of the hydrogen by any other group, you can remove all the three valencies, right? In this case, if at all you are removing only one, you are getting basically benzyl. You can relate to this. We name this as benzyl alcohol, no? Common name, benzyl alcohol. There is one hydrogen which is not there. In place of that, there is OH. Now, if at all 2 is free, that means 2 hydrogens you have removed. Okay. So the thing is, you are having something like this. It is called as benzyl. Do you remember that we call this C double bond OH as benzaldehyde? We just have one hydrogen connected to this carbon. It is benzaldehyde. Getting it? So benzyl is coming from here. If at all I remove all the three, that means I am freeing all the valencies. This is benzo. And I'll be having here like this. Benzoic acid, do you remember benzoic acid? So out of the three hydrogens which we have removed, those three valencies, it could be used in any way. Two of the valencies are binding with the oxygen and one with hydrogen. So basically, not with hydrogen, it is with oxygen OH group. This is benzoic acid. Are we getting it? Did we understand what I've written? Benzyl, benzyl, benzo. Please copy this, and this is only for, kind of comparison or understanding purpose. See, in this list only, I'm going to cover up for, neo, iso, everything here in the same list. Okay, they are all treated as substituents. Okay, now let us go for 7th one, which is normal. Normal, I'll be representing by N, and this is used for unbranched substituent. So for unbranched chain as substituent, right? So suppose if at all I write like this, CH3, CH2, CH2. So this is the place from where it will be connected to the parent chain. So I'll be calling this as N-propyl. Sometimes if at all this is not the substituent, that means CH3, CH2, CH3, I'll be calling that as N-propane, right? So this is clear, N-propyl for the substituent we are using. Then you are having basically iso. Now let us write down the general formula for this. General formula here is CH3. You are having here CH3, CH2N, right? And N here is 0, 1, 2, 3. Basically, this iso is only valid up to, isohexane. So this is basically, if at all I write here, suppose if N equal to 0, this is the general formula which you remember. If N I keep it as 0, this becomes CH3, CH3. This is the place from where you will be connecting it to the parent chain. And this will be known as, how many carbons are there? 3, na? Isopropyl. Getting it? And what will be the IUPAC name? This is a common name of it. What will be the IUPAC name of it? It will be 1-methyl ethyl. As such, in many books you will find out this iso is also written. But if it all, like, if you get like two of the options, this is the substituent like isopropyl only, but in one of the option its name is isopropyl, and in another option they have given you 1-methyl ethyl and the entire name with the parent chain, then definitely prefer this IUPAC one. There is nothing wrong in this, but the thing is, it is more acceptable, IUPAC name. Did we understand this? So it is like N equal to 0, it will become isopropyl. N equal to 1, isobutyl. Then isopentyl, isohexyl. Beyond that, this definition is not valid. Please write this down. Yes, are we done with everybody? Okay. Now let us proceed further. Now next is, suppose I am writing neo, right? So for neo, let us see what is the general formula. Here for general formula I am writing G dot F. So basically you are having CH3, C, CH3. Here also CH3, CH2, CH2N, right? And here N is only 0 and 1. Now what is the prime requirement for neo is you should have at least one 4-degree carbon. And adjacent, you are having this 4-degree carbon, adjacent to that you will be having this CH2, right? So if at all I put this, if N equal to 0, what you are going to get is CH3, C, CH3, CH3, CH2, CH2, N equal to 0, hai na? So this will vanish actually. Now you will, this particular group will vanish na, if at all I put N equal to 0. So this is going to be neopentyl. Now can anybody tell me what will be the IUPAC name of this? This is the place from where it will be attached to the parent chain. What will be the IUPAC name of this particular substituent? This is basically its IUPAC name of this isopropyl. Correct? I think somebody has written it correctly. Very good. Many of you have. 2,2-dimethyl propane is not the correct one, beta, because it is a substituent, right? Yes. So this is going to be 2,2-dimethyl propyl. This is the IUPAC name of it. Clear about it? Did we finish writing? Yes, majority of you were able to write it correctly. Very good. Okay. Written, everybody? Then you are having secondary. Secondary means you are freeing the secondary valency. Suppose if I write like this, CH3, CH, CH2, CH3. Are you able to realize this is the carbon? This is a 2-degree carbon from where I have freed the valency. And here only you will be attaching it to the parent chain. Now what is the name? This is basically secondary butyl. Right? Can you tell me the IUPAC name of it? Yes, 1-methyl propyl is absolutely correct, because the moment from, like the place from where you have freed the valency, there you have to give number 1. 1, 2, 3. So you're going to write down 1-methyl propyl. That's what is the name. Very good, right? Now, the thing is, next one is tertiary. We'll be writing either T, RT, or else sometimes only T. So basically now you can understand from tertiary carbon you are freeing the valency, right? So suppose I am having like this CH3, 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 like this it is, right? Or else simply you might be seeing something like this. This is like this, 1, 2, 3, 4. Here it will be attached. Getting it? So that's what is basically your tertiary butyl. This is tertiary carbon now. So tertiary butyl, T-butyl. What is the IUPAC name of it? Can anybody tell me the name? Oppo, I am telling at normal speed only. If at all you are having any doubt, you can tell me. You can ask me. When rest of the people are able to answer, that means somewhere you are lagging better. If at all you are having any doubt, you can tell that. The thing is, normally words per minute which are there for me, it is more only. If you don't understand anything, you ask me. I am ready to explain you again. But certain manufacturing defect, you cannot, kind of rectify them. Yes, so it is going to be 1, 2. This is 1, 1 dimethyl ethyl. Correct. Very good. Correct. Understood, everybody? What is secondary, tertiary, iso, neo? Now there is one note which I am writing. Iso, neo and cyclo are considered for alphabetic order. See, the thing is, do you know what is the difference between a simple substituent and a complex substituent? Do we know the difference? Suppose if I show you something like this. Out of A and B, which one is having simple substituent and which one is having like complex substituents? A is having simple substituent. That means there should not be any branching. Here you're not able to see branching here now. There is no branching in the substituent. Definitely this is only your parent chain. So definitely these two are what? Substituent. In those substituent you are not able to see any branching. So it is containing simple substituents. So I'll call them as simple substituents. Right? Here, are you able to see? This is the parent chain. This is your parent chain. This is the substituent, but it is having branching in it. So this is complex substituent. Clear about it? Now, having known how to basically name the complex substituent or all the type of, substituent, I'll give you one particular compound. You try to name it. Okay. Fine. Is that okay with all of you? Write the IUPAC name of the following. Or else I'll replace it by a simple substituent so that it becomes easier for you. I have given you only 2 of the molecules. You better try it. Ashwak, correct. Very good. Trishal also correct. Good. Very good. So basically this will be the parent chain 1, 2, 3, 4, 5, 6, 7, 8, 9. Are you able to see this is a complex substituent, right? Majority of you, Karthik also have given correct answer. Wonderful. Now the thing is, you can dash I am putting so that you can identify, okay, this is the substituent and you have to number it like this. So basically at which place? At 5. Then you'll put this complex substituent in the bracket. You are having 1-methyl ethyl. And then it is nonane. Now the thing is, you could also write this as 5-isopropyl. Is it not isopropyl? 5-isopropyl nonane. Both the names are correct. If this is not given in the option, go for this. It will be acceptable. If both are given in the option, then more correct will be this one, IUPAC one. Are we clear about it? There is nothing, no harm in this, right? In this case, what you are having is, this is only the principal chain because 1, 2, 3, 4, 5, 6, 7, 8 and here it is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the thing is, first name the substituent. This is 1-methyl ethyl and this is methyl. These are the 2 substituents. Now the thing is, what is the set you are getting? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And in fact, out of methyl, and first of all, we need to check for the set. If you are getting 3, 6, from here you will be getting anyhow more. But if suppose in any example, if you get the same set of locant and you are having methyl and you are having 1-methyl ethyl, then whom will you give the lower number? My question is, in this question, though, definitely from this direction you are getting the lowest locant, right? So what will be the name here? Let us finish off the name and then you can proceed with the question. So you are going to write down here 3-methyl, 6, 1-methyl ethyl, and then you are having nonane. If at all you are writing isopropyl, then I will come here first. Are we getting it? If at all we are writing the name as isopropyl, then I will be writing 6-isopropyl 3-methyl. I of isopropyl is considered for alphabetic order. Is this clear to everyone? Right? Now, let us focus on the question which I have asked you. I asked you one question that suppose in this question you are getting 3 and 6. Hai, it is very clear that you have to number from this side only. Okay. But what if sometimes you will be getting a tie that from either of the direction you are getting the same set of the locant. In that case, which one out of this methyl and 1-methyl ethyl should be getting the lower number? When you are getting the same set of locant, then only we give for the alphabetic order preferences, no? Which one? No, it's not like that you should be giving preference for complex substituent over the simple substituent. Again, alphabetic order you see. You are having methyl ethyl and you are having methyl. So after methyl is same. After methyl there is nothing. Here it is ethyl. So nothing is given preference over something. Getting it? There is nothing here. Here there is something here. So in alphabetic order, in case you are getting the same set of locant, you should be giving lower number to this. Is this clear to everyone? There is nothing like we are not partial towards, complex substituent. Clear? Okay. So yes, Karthik, which point you want to understand? This particular point only? This particular point only you wanted to understand, Karthik? Yes? Okay. See, the thing is, my question is, in this question, though, okay, fine, you got to know where, from which direction you are numbering, and you are getting this different set of locant. So you decided, okay, only from this end when you approach, you'll be getting a lower set of locant. But what if it may happen that you have selected the parent chain, you started numbering from, suppose, left to right. You got, suppose, 3 and 5, suppose. From right to left also, when you started numbering, you got 3 and 5. But this time, 3 for methyl, ethyl, 5 for methyl. But this time it is 3 for only methyl and 5 for methyl ethyl. My question was, which one would you prefer? Who should be getting preference for the alphabetic order? The thing is, you compare. You are having methyl ethyl, here only methyl. Methyl is same, na? After that, after methyl, there is nothing. Here, after methyl, you are having ethyl, right? So there is something, there is nothing there. So that gets the preference. Getting it? Because it seems like something is still there. Here, it is nothing. The name has ended. Are we clear about it? Karthik, I hope your confusion is clear. Right? Okay, good. So with this, we finish off the naming of alkanes and a saturated hydrocarbon. Now we are moving towards naming of alkene and alkyne. Okay. So let us go for IUPAC naming of alkene and alkyne. Now in this case, similarly, the way I have given you for, the order to how to select the parent chain, similar way we are going to write down for them also, right? So for selection of parent chain, first of all, you have to see maximum number of multiple bonds. Then you have to see maximum number of carbon atoms. Then you have to see maximum number of substituents. Then you have to go for lowest set of locants. Then you see for alphabetic order. That means what I am writing here is, if you carefully see, I have just added one more thing. Rest it is same as what you have seen in alkane. Is it not the case? Rest everything is same except this maximum number of multiple bond. It's absolutely same. That means what is the first thing which you need to see? Try to include this as many as multiple bond. That means all the multiple bonds if possible, and then try to make the longest possible chain. Getting it? You should not only focus on making the longest chain without inclusion of that multiple bond. And that multiple bond could be of double bond or else it could be of triple bond, right? If that is also same, then you go for maximum number of carbon atoms. If that is also same, then you look for that particular will be the parent chain which is having maximum number of substituents. If that is also same, then you look for from which direction you are getting the lowest set of locant. At that way you start numbering. And if that is also same, in that case, whichever substituent is coming earlier in the alphabetic order, it gets the lowest number. Please first write this. And I'm writing down certain rules here. Then I'll explain you all the rules with certain example. Is that okay with all of you? We are going to write down certain rules here. Okay? So fine. If the molecule contains more than one double bond, then use alka as the word root. You add an additional A there, right? Then another rule I am writing, if the molecule contains more than one triple bond, that means when I am talking about more than one double bond means only double bond should be there. Here also only multiple triple bond should be there. There should not be a combination of double bond and triple bond, right? Then use this as word root, right? Alka. Add, general word root is alk. Suppose pent is there, you make it penta, or else hex is there, make it hexa. Okay. So able to understand these two rules I have written. If there are more than same type of double, but the double or triple bond, but more than once, and there is not the mixture of them. More than one, maybe 2 double bond, 3 double bond, 4 double bond in the same molecule, right? Maybe 2 triple bond, 3 triple bond in the same molecule. You don't have the combination of those two. Is this point clear to you? Now, if the molecule contains both double and triple bond, then its name is given by Alkene. What is this blank space telling you? It is the position of double bond. And what is this telling you? It is the position of triple bond. And are you able to see? Normally we write down ene as this. And the thing is, I have dropped this terminal E. Right? Yes, correct, Karthik, right? We have dropped this terminal E because the thing is, whenever it is double bond and triple bond, so you are treating your double bond or else alkene as a primary suffix in comparison to or else with respect to alkyne. That means you are writing the name as if it is derivative of alkyne. Okay. So I'm writing here one thing. Alkene is treated as primary suffix with respect to alkyne. And I'm writing one more rule. If the primary suffix has a numerical affix associated with it, then also use the word root alka, right? You need not worry about this particular rule which I have written. You'll understand this eventually when I'll tell you the example. Don't become impatient at all. Just keep patience for some time. You'll be fine. Absolutely, you'll be able to sail through it. Okay. Now, next is if secondary suffix starts with A, E, I, O, U and Y, then terminal E of the primary suffix is dropped. So make sure you are writing them and then we are going to see few examples and after that you will be fine, absolutely comfortable naming them. And there is nothing like giving preference to, double bond over triple bond. And I don't think there is some kind of preference we give it more to double bond or triple bond, unless and until we are getting the same set of locant and the other factors. That means the longest chain, the number of substituents, everything remains same. At that time only your double bond, which starts with ene, is given preference over ine. That means we are even going for the alphabetic order, right? So I'll write down that rule as well. Note, double bond is given preference over triple bond only if we get same set of locants and rest of the factors remain same. Rest of the factors remain same. Please write this down, then we'll start looking at all the rules which we have seen. Yes, Oppo, are you added in the group? Are you added in the group which is officially created? I'll share in the group, then you need not worry about it. Okay. If somehow some people are struggling to write, not an issue. Weekend syllabus, it is there, no? Up to cyclic hydrocarbons. It will get covered today only. Don't worry about it. That is the reason I have taken a long slot. Are we done writing? Let us see some questions now. So the simplest ethene which you can have is like this, alkene. It is ethene. Now the thing is, if I give you like this, and always remember, try to give the lowest possible number to your double bond. So what is the name I'm going to give for this? Tell me. In fact, this is the kind of thing which you already know. So you can help me out in naming here. These are all very simple. Wherever typical comes, I'll tell you. What is the name of this compound? You have to write down but1ene. Because you are also having this compound which is basically but2ene. So there should not be any room for any, kind of confusion. Okay. Suppose if I write something like this. What will be the name for this? Let me write down this as chlorine. What will be the name for this? Since I am asking the very simple question, so the thing is, if at all I am numbering, I'll be getting 1, 2, 3, 4. So I should first focus on my multiple bond, right? It should be getting the lowest possible number. Now the thing is, you can also go like this, 1 dash, 2 dash, 3 dash, 4 dash. Now check, when I went from this side, dash side, is the position of locant or else locant changing for my double bond? It's the same, na? Yes or no? Now the thing is, if it is same, then I'll go for that particular direction where I can also do some favor to my substituent. Normally, I don't pay much attention to substituent, but only if by going from either of the direction or any direction, I'm getting the same set of locant for my multiple bond, then I worry for this. Otherwise, I don't, right? So here it will be 1 bromo but2ene. What about this? There is no option because the thing is my double bond will be getting more number if at all I'm coming from here, and which is not acceptable. So this is going to be 3 chloro pent, you are having 2ene. Clear to everyone what we are writing over here? I'm giving very, very simple examples at present. And hopefully you are also writing in your notebook. Okay. Now the thing is, let us say I'm giving you something like this. How would you name it? There is a triple bond, there is a double bond. What I should focus on? See, the thing is, when we have written lowest set of locant, na, so there we must take care of first my like functional group. If at all it is any there, it is present there, so that should be getting the lowest number. If functional group is not there, then I need to worry about the multiple bond. And then in the last, the substituent. Lowest set of locants, that should be designated lowest for the functional group. If functional group is not there, then I'm going to go for the multiple bond, and then I'm going to worry for my substituent if possible. Now the thing is, see here, I should only look for my multiple bonds. Here I'm getting 1 and 3 and as the set, and that should be preferred. People have gone for the reverse way because you tried to save your substituent and that will give you -1. Are we getting it? So I'm going to write this as 4-bromo pent 3-ene, and then you are having 1-ine. Is this clear what I have written? Clear to everyone? 4-bromo pent 3-ene, 3-ene and 1-ine. Clear? No confusion here? Now what if I write something like this? A triple bond here, a triple bond here, a triple bond here. What will be the name you are going to give for this? Here 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Now the thing is, more than one triple bond. I don't have any double bond here. So basically I'm going to write down non. I would be writing for 9, but here Alka word root, add an extra A. No, Vivo, that's not the correct answer, beta. Right? So this is going to be nona, and then you are having what? 1, 4, 8. Triine. Is this clear to everyone what I've written? From where you have got this ene, hex 3-ene, 1,5-diene, beta, I don't know, because it's like all triple bond I have given. Is there any confusion to anyone in this name? I have written nona because non. Non is basically alk. This is alk. Add an extra A. Is there any confusion to anyone here? And what is the position? 1, 4 and 8. Are bromo is not there. Who is this? Beta, where the specs, beta? Bromo is not there. Where I have kept bromo? Now I am giving you another one. You please try the name. Try out the name. Previous one, why not? What is your doubt, Minoti? Why not 2-bromo? Because the thing is substituent. It is substituent. I don't worry about the substituent. My first focus should be on the multiple bond. That should be getting the lowest possible number. Please listen to the lecture carefully. That's my humble request. Correct, Karthik? 1, you will be starting from 1, 2, 3, 4, 5, 6. In fact, you should check once here from here also. 1, 2, 3, 4, 5, 6. Hai? So basically, this is the only best possible way, because when you are coming from this, you are giving lower number to the substituent, right? So you are going to write down this as 3-fluoro. You are having hexa 1,3-diene. That's the correct answer. 3-fluorohexa 1,3-diene. Now I'll give you one more. Give it a try, all of you. Sorry, let me just write down here. What will be the name for this? I'm writing two more here. I think people have written. See, the thing is, you might feel like, okay, let me include this one. It is 1, 2, 3, 4, 5. If at all you include, try to include these two double bond in the parent chain, you'll be getting 1, 2, 3, 4, 5 carbon chain only. But if at all you go like this, 1, 2, 3, 4, 5, 6, 7. So this is the way you select the parent chain. Now, when it comes to numbering, 1, 2, 3, 4 from here, 1, 2, 3, 4 from here. So either way you can go. Now, can you identify the substituent which you have learned today itself? In today's class only I have taught you. What is this fourth substituent? You don't think that something is missing over here. Basically, it's double bond CH2. Methylene or methylidine. Correct. Wonderful. Very good. So, you are having 4 methylidine. Then you are having hepta 1,6 diene. Clear to you? You could have also written methylene, not an issue in that. Methylene would also have been correct. Did we understand? For those people, is there any confusion in this name? Now the thing is, here you don't get confused that I have to include a double bond and triple bond or else anything like that. You just treat double bond and triple bond as multiple bond with them. Okay. So by treating them as multiple bond, you just see that by including the multiple bond, which is the longest possible chain, whether it is the double bond or else multiple bond of a double bond or else of a triple bond. Getting it? So in that case, you are going to get 1, 2, 3, 4, 5, 6, 7. And this becomes what? Your substituent. And today's class only we have learned 3-ethinyl. And you are having hepta 1,6 diene. Clear to everyone? Now what if I give you very simple one now? CH2, let us say like this. A double bond. There is a double bond, there is a triple bond also. I have given you a very simple one. 1, 2, 3, 4, 5, 6. The thing is, either you number from here 1, 2, 3, 4, 5, 6. You are getting the same set of locant. Both of them they are terminal. Ene also, yne also. Length of the carbon chain is also not changing. That means your parent chain is also same. There is no substituent here. Nothing is changing here. So basically, who will be getting preference over here? It will be basically your ene. So I'll be writing hex 1 ene 5 yne. Getting it? As such, there is nothing like we prefer ene over yne, but only if when there is a tie. That means from either of the direction you are getting the same set of locant for both double bond and triple bond. In that case only you are giving lower number to alkene over yne, ene over yne. Is this point clear to everyone? I hope you people are writing also simultaneously in your notebook. Which one, Priya, you want to understand? This one? See, in this case, normally see, we treat double bond and triple bond as if they're multiple bond only, right? Now the thing is, here when you number, suppose I write it again, right? Now the thing is, I can also number like this. You can argue, ma'am, we can write like this also. Write it. What is the set of locant I am getting here? 1, 5. Here also I am getting 1, 5 or not? So I am getting the same set of locant in both the cases, whether I number from left to right or right to left. Yes or no? Now the thing is, when there is a tie, that means from either of the direction, you are getting the same set of locant for both double bond and triple bond. So in that case, here I am getting this for ene. This one is for ine. Here this one is for ine. This one is for ene. So which one is earlier in the alphabetic order? Ene or ine? Ene or ine? Priya, answer beta. E comes earlier or Y comes earlier? Ene. So that is the reason I'll be preferring it. I hope you understood this. Hai? I won't be preferring this numbering. Clear? Okay, good. Now I have given one more example, like two more examples to make you understand one rule which I told you that you don't get anxious about. I'll make you understand that. Okay. Now in this case, see, I'm going to number it like this: 1, 2, 3, 4, 5, 6, 7, 8. Can I get any other number like this? 1, 2, or in fact 1, 4 and 7. If at all I number like this: 1, 2, 3, 4, 5, 6, 7. The same thing I'm getting. Now the thing is, your double bond is a primary suffix. Your triple bond is a secondary suffix. Right? I told you that we have written now that double bond or alkene is treated like a primary suffix in front of your secondary suffix, which is your basically alkyne. Right? Now, alkene is only appearing once. It's not appearing more than once. So, when I say you have got the numerical affix associated with the primary suffix. Numerical affix means whether it is diene, triene. I don't count monoene like that. There is nothing like monoene. So, I am saying that your double bond is only coming once. Right? And double bond is primary suffix. It doesn't have a numerical affix associated with it. So what will be the name here? Oct. I won't be writing octa. First of all, oct. Then 4-ene. And then I am having 1,7 diene. Are you able to see? I didn't drop the terminal E because this was starting, secondary suffix was starting with a consonant D. It was not starting with a vowel or Y. Why Y? Because Y is sounding like I, Y, like that. Let us see another example. Here if I number 1, 2, 3, 4, 5, 6, 7, 8. If I number here, what is the set I am getting? 1, 4, 7. Here 1, 2, 3, 4, 5, 6, 7. Same set I am getting, right? Now the thing is, you try to understand the relation between these two. In the sense, I have, kind of reversed. Here I have taken 2 triple bond, 1 double bond. Here I have taken 1 triple bond, 2 double bond. 2 double bond means I will be writing diene or not? Diene. So di is something numerical associated na, and ene is what? A primary suffix. So here I'll be getting octa, then you'll be writing 1, 4 diene, and then you are having not 1, 4 beta, 1, 7 diene, and then you are having 4-ine. Did you understand the difference between these two? Why I have used octa here? Because this is my primary suffix, ene. It is having numerical affix, which is di. Yes, I'll repeat, Karthik. Just be patient here. Understand one statement. If at all you are having like only double bond and triple bond, right? First, let us simplify it. You are having double bond and triple bond here. Okay. Now, in this case, double bond is treated as a primary suffix and triple bond is treated as a secondary suffix. Up to that, it is clear to all of you. Is that clear? Double bond, I am treating it as a primary suffix with respect to my alkyne. Is this clear? There should not be any confusion. Now, the thing is, here how many double bond I am having? 2. It could be more than 2 also, right? So, I will be writing diene if at all it is 2 double bond. So, I am saying there is a numerical affix something numerical which is telling you di, tri like that, I'm calling that as a numerical affix. It is associated with -ene, your primary suffix, which is the -ene. Up to this it is clear? Up to this people are able to follow? Karthik, up to this, are you clear what I'm trying to say? What is a numerical affix which is associated with primary suffix? Yes. Now, when that is the case, a numerical affix associated with a primary suffix, in that case, what I use? I add an extra a to the word root. Got it? Up to this clear? Now, the reverse scenario is above. I have got basically -ene, which is a primary suffix, but it is coming only once, right? No, don't carry that misconception, beta. Vowel E is present. No. We don't say like that. Now here you are having basically what? This primary suffix, it is coming only once. If it is coming only once, I won't be writing mono-ene. So you don't have a primary, like you don't have a numerical thing associated with this primary suffix. So in that case, I won't be adding an extra a to the word root. Vowel and everything has to do only with the secondary suffix. If the secondary suffix starts with a, e, I, o, u or y, in that case only you are dropping the terminal e. Otherwise, you are keeping it intact. So please don't hybridize the two rules. That is my humble request. Here, see, I have dropped it. I have dropped e because here it was secondary suffix was starting with y. Is this clear now? So we have covered all the rules. Yes, with this alkene alkyne over, we'll move on towards the cyclic hydrocarbons. Is that okay? Please carry all these rules in your mind when we'll be dealing with the cyclic hydrocarbon, because cyclic hydrocarbons, we'll be seeing the example for saturated, unsaturated all together. Clear? Can we proceed further? So let us go for IUPAC naming of cyclic hydrocarbons. Now here also for selecting the parent chain, it is the same rule which you have written for alkene and alkyne. So I'm just going to write it again. Okay. So selection of parent chain, you are having maximum number of multiple bond, then maximum number of carbon atoms, then if that is also a tie, then you look for maximum number of substituents. If that is also a tie, then you go for lowest set of locants. And we talk about lowest set of locants now, then functional group is given more priority over the multiple bond, and then you are having basically the substituents. And then if everything is same, it is alphabetic order. I have just written the same order or selection procedure which we have done for the previous case, right? I am writing here note, if all the factors are same for cyclic and acyclic part of molecule, then cyclic part is taken as parent chain. If everything is same, there is a tie, then cyclic wins over acyclic. We'll see example, you don't worry about it. First you write this down. MB is multiple bond, beta. MB is multiple bond. Here, shortcut for this. FG is functional group. Yes, are we done writing? Then we'll jump on to the naming. Yes? Okay. Now, let us see if at all I give you this. Tell me which one will be the parent chain. There is no multiple bond involved here, right? So just go for the next one, which is the maximum number of carbon atoms. Here you are having 6 carbon atoms, so that will be forming the parent chain. This is the parent chain. How do you name this then? It is going to be methyl cyclohexane. Able to understand? We are following the same thing. 2 degree prefix plus 1 degree prefix plus you are having word root plus 1 degree suffix plus 2 degree suffix. So we have written the substituent, then we have written 1 degree prefix which is cyclo here, and then we have gone for the word root. Clear? Now suppose if I write like this, which is the parent chain? Ring or the side chain? This or this? Which is the parent chain? Ring. Because you are having here 1, 2, 3 carbon only. So this is my parent chain. If this is the parent chain, what I am going to write? Propyl cyclobutane. Able to understand? Good. Now, let us take it further. Tell me which is the parent chain now? Is this outer one or this ring? That open chain, correct. So I'm going to write like this, 1, 2, 3, 4. I'll be writing 2 cyclopropyl and butane. 2 cyclopropyl butane. Got it? It's good to see people are able to understand. Very good. Right? So when you will be like focused, you will be able to learn. Good. Now, which is the parent chain? Ring or the straight chain? Ring. Very good. When there is a tie, everything, every factor same, then ring will be given the preference. Now here, this is the substituent. So can I write this as 1-methyl ethyl cyclopropane? We're able to see this is 1-methyl ethyl, which is your isopropyl. Isopropyl is also acceptable, but the thing is it should be given in the option, right? Now, which one will be the parent chain now? Ring or side chain? Ashwak, check your answer, beta. Check it. Don't be impatient. Check it. Yes. The thing is here, if you see, carbon atoms are same. Here 1, 2, 3. Here also 1, 2, 3. But in this case, once the chain is same, then we have to go for what? Maximum number of carbon atoms. That is also same. There is a tie. I have given you that order for something, there is some utility of it. After that, we check which has got the maximum number of substituents. If at all I consider this as the parent chain, then I am having only one substituent. But if I consider this as the parent chain, I am having 2 substituents. You are having 1, 2, 3. Getting it? Now, out of these 2, I am having chloro and I am having cyclo. And do remember that we have written that cyclo, CY will be considered for the alphabetic order. So you are having CH and CY, right? So I'll be writing 1 chloro, 2 cyclopropyl, and what you are having is propane. 1 chloro, 2 cyclopropyl propane. Is this clear? And hopefully you people are writing, you know, when you are answering, you are writing also along with me. Yes? Is there any confusion to anyone for this? In that case, now you name something here, you know, which I am writing. At least name them. I have given 4 for you. We always need to look for the lowest set. So it is, I am going 1, 1, 2, right? So I'll be getting this as 1 bromo, 1 chloro, 2 methyl, cyclopropane. One bromo, 1 chloro, 2 methyl cyclopropane. Okay, very good. Wonderful, na? Ashwak, Mithun, I think Minoti. Minoti is the correct name, your name only. Huh? Because it's a unique name, I don't know what's the meaning of it. No, yeah, that's odd. People will be creating typical names. Here, you'll be writing 1 ethyl, 2 methyl, cyclohexane. Yes, correct. We were getting the same set of locant now. Then whichever is coming earlier in the alphabetic order, that should be given preference. Okay. What about this? See, this substituent is methyl. And this substituent we very well know it is 1 methyl ethyl. So which should be given preference? Which should be getting lower number? I should number like this and I should write 1 methyl 3, 1 methyl ethyl, cyclohexane. If at all, why 2, 4? From where you will be getting 2, 4? It should be only 1 and 3, na Gitika? If at all isopropyl is given in terms of isopropyl, then you should be getting 1 number for this. 1, 3 should be there. 2, 4 will never come. Okay? Don't do silly mistake. Here, I should be writing 2 bromo, 1 chloro, 1 methyl, cyclopropane. Have you written this one? 2 bromo, 1 chloro, 1 methyl, cyclopropane. Now let me give you another. Sometimes the examiner can also write ET or ME. ET is for ethyl, ME is for methyl. Tell me what is the number which I am going to give here? You'll be trying to give the number in such a way that you are getting the lowest set of locant, right? And then you have to write down in the alphabetic order. So C comes earlier, 2-chloro, 1-ethyl, 4-fluoro, cyclohexane. That's how you are going to write down. 2-chloro, 1-ethyl. Why 3-ethyl? If at all, see, somebody is asking me, ma'am, why didn't you start from chloro? Okay, let me take it. See here, what is the set I am getting for the substituent 1 to 4? Am I getting that? Now here, if at all I start, what is the set I am getting? 1 to 5. Which set is lower? One to 4. That is the reason I didn't give this. Clear? Understood the person who has asked me that doubt? Yes? Okay. Now let us make these examples little bit more interesting. What is the name I am going to give? Always more preference to and do remember whenever you are having like double bond, it should be between 1 and 2. Always 1 and 2 given to that. So the thing is, I am going to give 1 and 2. After this only this is there. So 3,4 dimethyl cyclobute-1-ene, or else cyclobutene also will do, because if it is only 1, so it is understood that I could have written cyclobutene also. What about the name for this? 1, 2 is fixed. So I'm going to give 1 bromo. Then what you are having is 2 chloro cyclobutene. Is there any doubt to you? 1 bromo, 2 chloro. What about this? 1, 2, 3, 4. I'll be writing 4 bromo, 1 chloro cyclobutene. Is there any doubt to anyone in this? Is there any doubt? Is there any doubt here? Chlorine, bromine. Don't, I have given like this 1, 2, 3, 4. If at all I go like this, suppose somebody is saying, ma'am, if at all I can give like this. Okay, but what is the set of locant you are going to give for your substituent 2 and 3, which is going to be higher? Gitika, which one you are telling me, beta? For this one, you won't be writing 1 and this one is bute-2-ene. This will be wrong. In this case, second one, it will be wrong, beta. You got it correct. Like, did you understand why I'm not taking like that? I cannot put like this also. You are saying like this, na? You are saying I should give number 1 to this. But the thing, then it will be like what? I'll be giving, if it is for this second one, it is correct. If it is for second one, it is correct. If it is second, then fine. Absolutely fine. Okay. Then I am mistaken. Sorry for that. Okay. Tell me, this is an interesting example. I should number like this 3, 4, 5, 6. I'll show you all the possibility which your mind can think. Somebody might be saying, ma'am, 1, 2, 3, 4, 5, 6. है ना? This is wrong because you cannot have 1 and 6 here. It has to be for a double bond, you have to give 1 and 2 only. So this is going to be 1, 6 dibromo cyclobutene. Okay. Can you answer the other one which I am writing now? Correct. Cyclobutene is wrong by mistake. Sorry for that. It is cyclohexene, correct. Good. So it looks good when people correct you because then it seems like, okay, people are awake. Good. No, but at 2, 3, you are giving the higher set, na, Karthik? When you are taking 2, 3, which set is higher? 1, 6 and 2, 3. You have to compare. The thing is, when you get this point of difference, this is lower. You need not worry about the next one, whether it is higher or lower. I think that is what is your confusion. You are getting these two set, na? If at all you are going by this. Otherwise, you are getting 2, 3. You don't go for, summing them up. There is nothing like lowest sum rule. We just compare by lowest set of locant. Clear? So this I am not going to prefer. The moment I get the first point of difference, in whichever set I am getting the lower number, that is the preferred one. This is going to be 1, 2, 3, 4. So it is 1, 2, 3, 4. Always my attention should be on the multiple bond. Somebody has written, but it is wrong. This is going to be, first you write down the substituent, 5-bromo. Then you'll be writing cyclo and then penta, you will be writing more than one double bond here. Cyclopenta. And then you're writing 1, 3 diene. Did you understand what I've written here? It is 5-bromo. Cyclopenta I am using. Extra A when you are having more than one type of similar bond. 1, 3 diene. Is there any confusion in this name? Did you people understand what we have done here? Tell me what will be the name for these two. 1, 2, 3, 4. I'm going to write 2-chloro cyclopenta. 1, 3 diene. And here 1, 2, 3, 4. 1 iodo cyclopenta. 1, 3 diene. What is the name of this particular thing? I've given you a simple example. After all these examples, a simple example. This is the parent chain, na? 1, 2, 3, 4, 5. So I'll be writing 1 cyclobutyl pentane. And mind it that I need to write down one position here because this ring could have been at second place also, third place also. Clear? Did you understand what we have written? One you have to write down because there could be like position change for this now. I could have attached here also at 2 position also or 3 position also. So you should not leave any scope of confusion while writing the IUPAC name. Now here, which one is the parent chain? Definitely whichever is having the double bond. So this I'll be writing 3 cyclopropyl cyclopentene. Did you understand what I have written? 3 cyclo. I need not write down with a cyclopent1-ene because it is understood that if it is only 1 pi bond, it will be there only. It will be given 1 and 2 position only. If you are writing also, then also it's not wrong. But if in the option it is not given, then you should not, declare that it was not given and you didn't tick mark the answer. Out of these two, this one will be treated as the parent chain, multiple bond. Getting it? Maximum number of multiple bond, then the number of carbon atoms come into picture. Right? So in this case, it is going to be 1, 2, 3, 1 cyclohexyl cyclopropene. Clear about this, everyone? Understood? Yes? So with this, we finish off the naming of cyclic hydrocarbons as well. And you please prepare for the test up to this portion. Okay? And I'll share this QR code in the group. Those who are there, those who are there in the group, you'll get it. Karthik, are you in the group? Then you will get it. I'll share that. Fine. So wish you all the best for the test and definitely be very careful when you are naming them. The questions are very simple. Only thing is the way we read them, or else how much we are able to concentrate on the particular question, that makes the difference. Otherwise, questions are not difficult. Okay. So wish you all the best for that. Okay. Thank you and have a nice day.